Okay, now we discuss about Bohr's atomic model. So before Bohr's atomic model, there is a many number of atomic models are there. In them, the first one is the Thomson's atomic model, and the better one when compared to the other models is Rutherford atomic model. But there is many drawbacks in the Rutherford atomic model. So even it is a better one. Even it is a better one when compared to the all earlier models than Rutherford. It is better one. It has many merits, many good better points when compared to the earlier atomic models. But it has many demerits. It has many demerits. What are the demerits? We see two main demerits in it. It does not explain stability of atom, and even it does not explain line spectra of atoms. According to Rutherford, atomic spectra is a continuous spectra, but experimentally we see that, for example, hydrogen spectra, all atomic spectra are line spectra. So it is failed to explain the many properties of atoms. And after a few years, Niels Bohr given his atomic model, which is based on, so Niels Bohr's atomic model is based on some assumptions of quantum physics, and it is also taken some assumptions from Rutherford atomic model. He also taken as a reference, that is Planck's quantum theory. Bohr's atomic model is based on Planck's quantum theory. Some assumptions taken directly from Rutherford atomic model, and by the study on the quantum physics, he was able to give his new atomic model. Okay, so now we see the main points in the Bohr's atomic model. Okay, now we see the important postulates. Important postulates in Bohr's atomic model is the number one. The electrons present in the atom revolve around the nucleus. In a fixed, these all terms are important. These are the fixed circular paths. Electrons revolve around the nucleus in a fixed circular paths. So fixed circular paths are treated as orbits, denoted with the principal quantum number n, nothing but just a letter n. So the fixed circular paths are having nothing but these orbits are having fixed amount of energy, a definite amount of energy. That's why they are also treated as energy levels. Their energy fixed, stable, standard value. That's why they are also known as stationary states. Generally, they are named as first level, second level, third level, fourth level, etc. They named with the K, letter M, Mn. So these one are nothing but K are sought from the nucleus. Okay. For example, this is the atom, the positive charge. This is the first level. This is the second level. If this is the third level, the fourth level. The first level nothing but is a K, L, M, N, etc. Okay. So this is the main point in the Bohr's atomic model. Okay. See the next one. Okay, see the second important one. The electrons revolve around the nucleus in a fixed orbit, we know that. But while electrons is revolving, revolved electrons possess angular momentum which is equal to multiple integral of h by 2 pi. Means, so already we said that electron revolving a fixed circular orbit. At electron fixed circular orbit lo revolve ayetapudu aa electrons they must exhibit some angular momentum. Revolve aye particle denikana angular momentum anedi untadi. So angular momentum enta untadante it is multiple integral of h by 2 pi. అంటే h by 2 pi కి మల్టిపుల్స్ ఉంటాయి. అంటే 1h by 2 pi, 2h by 2 pi, 3h by 2 pi like that. So this can be written as mvr is equal to nh by 2 pi. Okay, this is the basic equation and very important equation from the Bohr's atomic model. So this is also known as quantization of angular momentum. And angular momentum value ni a specific equation so we are able to calculate with the help of this equation. So that is called quantization of angular momentum. Here very important, m is equal to mass of electron, v is equal to velocity of electron. The important r is equal to radius of orbit at which electrons is revolving. Okay, electrons a orbit lo revolve avutundo dani radius. Next, n equal nothing but number of orbit. Number of orbit అంటే 1 2 3 వే ఉంటాయి. మనకి ఫ్రాక్షన్స్ లో వచ్చే ఛాన్స్ లేదు ఇక్కడ ఏం వాల్యూ. h is Planck constant. Planck's constant. In the pi value we know that there is 3.14 approximate. So this is the very important point in the Bohr's atomic model. It is also comes under the merits of Bohr's atomic model in which the angular momentum of revolving electrons is quantized. Okay. Okay, see the next one. So here, as long as electron revolving in a orbit, there is no losing and there is no gaining of energy. Means the energy of electron present in an orbit is fixed. Already మనం starting లో చెప్పాం. The energy levels, these orbits are also called energy states, nothing but stationary states. అంటే దాంట్లో ఆ స్టేషనరీ స్టేట్స్ లో ఉన్నంత వరకు, ఆ స్టేషనరీ ఎనర్జీ లెవెల్లో ఉన్నంత వరకు దాని ఎనర్జీ మాత్రం కాన్స్టెంట్ గా ఉంటుంది. Means that this can be right in terms of the energy of an electron in an orbit is constant. అంటే ఆర్బిట్ లో ఉన్నంతసేపు దాని ఎనర్జీ మాత్రం కాన్స్టెంట్. Here another important point related to this is if an electron jumps from nothing but moved to if an electron moves nothing but jumps from lower level to higher level. So electron lower level నుంచి higher level కి వెళ్ళింది అనుకోండి. So at the time electron absorbs energy, or exactly reciprocal to it. If an electron moves from higher level to lower level, so higher level నుంచి lower level కి వచ్చింది అనుకోండి, then electron emits some energy. Okay, as long as electron present in that orbit, the energy will be fixed, energy will be constant. If due to the some any other factors, any outside force, if electron moves from lower level to higher level, it absorbs some energy. If electron shifts, that is, but moves from higher level to lower level, electrons emits some energy. Now how much energy releases, how much energy absorbed? So it depends on the higher level and lower level difference. So for example, here we are taking on different levels. This is first level, second level, third level. Its energy is E1, its energy E2, its energy E3, like this. Okay, if electron jumps from nothing but jump to first level to second level, అంటే ఫస్ట్ లెవెల్ నుంచి ఎలక్ట్రాన్ సెకండ్ లెవెల్ పోయింది. సో ఫస్ట్ లెవెల్ కంటే జనరల్గా సెకండ్ లెవెల్ అనేది సమ్వాట్ మోర్, కాబట్టి లోయర్ లెవెల్ నుంచి హైయర్ లెవెల్ పోతే ఎనర్జీ అబ్జర్వ్డ్ బై ద ఎలక్ట్రాన్. సో ఇక్కడ ఎలక్ట్రాన్ ఏం చేస్తుంది, అబ్జర్వ్ చేస్తుంది. అంటే ఎంత ఎనర్జీ అబ్జర్వ్ చేస్తుంది, దట్ ఈస్ ఈక్వల్ టు డిఫరెన్స్ ఆఫ్ దట్ energies. Mean here that is delta E is equals E2 minus E1. అంటే ఎంత ఎనర్జీ డిఫరెన్స్ ఉందో అంత ఎనర్జీని అక్కడ అబ్జర్వ్ చేస్తుంది. ఓకే, ఫర్ ఎగ్జాంపుల్ సెకండ్ లెవెల్ నుంచి ఫస్ట్ లెవెల్లోకి ఎలక్ట్రాన్ వచ్చింది అనుకుందాం. సెకండ్ లెవెల్ నుంచి ఎలక్ట్రాన్ మూవ్డ్ ఫ్రమ్ సెకండ్ లెవెల్ టు ఫస్ట్ లెవెల్. సో సెకండ్ లెవెల్ టు ఫస్ట్ లెవెల్ వచ్చిందంటే లోయర్ లెవెల్కి వచ్చింది. when it comes from higher level to lower level, it emits some energy. అంటే ఎనర్జీ ఎంత ఎనర్జీ ఎమిట్ చేస్తుంది, అగైన్ ఇట్ ఈస్ ఈక్వల్ టు E2 మైనస్ E1. అంటే అబ్జార్బ్ చేసిన ఎమిట్ చేసిన డ్యూ టు ద ఎగ్జైటేషన్ ఆర్ డి ఎగ్జైటేషన్, లోయర్ లెవెల్ నుంచి హయ్యర్ లెవెల్కి వెళ్ళినా హయ్యర్ లెవెల్ నుంచి లోయర్ లెవెల్కి వచ్చిన అబ్జర్వ్ చేసే ఎనర్జీ నథింగ్ బట్ ఎమిట్ చేసే ఎనర్జీ ఈజ్ ఈక్వల్ టు the energy of the difference in the energy of that two levels, the difference in the energy of that two levels. Generally it is written as E higher level minus E lower level. So ఇక్కడ మనం 1,2 example తీసుకున్నాం కాబట్టి E2 minus E1. So it can be written as E higher level minus E lower level, E higher level minus E lower level. Okay, so the change in the energy is delta E is equal to E higher level minus E lower level. I think we know that generally an equation is E is equal to h nu according to Planck's quantum theory. So delta E means it is also energy form, but here energy is difference in the energies. Mean here we can write E h minus E higher minus lower level equal h nu. It can be written as mu is equal to E higher level minus E lower level by h. So this calculation gives the frequency of the frequency of that energy radiation which is released or absorbed in the excitation or de-excitation process. And electron higher level లకు వచ్చినప్పుడు absorb అయ్యే ఎనర్జీ, ఎలక్ట్రాన్ లోయర్ లెవెల్ కి వచ్చినప్పుడు ఎమిట్ అయ్యే ఎనర్జీకి సంబంధించిన ఫ్రీక్వెన్సీ ఎలా క్యాలిక్యులేట్ చేయొచ్చు అంటే E higher minus E lower by h. So this is an important formula in Bohr's atomic model, which is known as Bohr's frequency rule. Which is known as Bohr's frequency rule. Okay. And a very important thing in the Bohr's atomic model is he also given many expressions. He given many expressions. Expression means here we can say that equations. Okay, he given many expressions. For example, given an expression for radius of an orbit. Radius of an orbit. Radius of an orbit is given as here r equal to n square h square by 4 pi square me square into z. So this is the radius equation. If actually at first it was given only for hydrogen atom by taking z is equal to 1, but afterward it is somewhat changed to apply the all atoms. Okay, so here radius of nth orbit means in this formula r equal to radius. We need to exactly by heart this expression. We know that h equal to Planck's constant. M equal to mass of electron. Here important one, what is E? E is again the charge of electron. Okay, Z is equal, we know that atomic number N equal to number of orbit where the electron is present. అంటే మనం ఏ రేడియస్ క్యాలిక్యులేట్ చేయాలనుకుంటామో సో దట్ వాల్యూ n వాల్యూలో సబ్స్టిట్యూట్ చేస్తాం. సో హియర్ యు సీ this radius and n is the change one. ఇక్కడ ఉన్న దాంట్లో వేరియబుల్ ఏంటంటే n అంటే అది ఫస్ట్ ఆర్బిట్ కావచ్చు, సెకండ్ ఆర్బిట్ కావచ్చు. ఇప్పుడు n అంటే మనకి 1 2 3 ఏదైనా ఉండొచ్చు. సో Planck's constant is a constant, no change. Mass of electron, no change. Charge of electron, no change. Pi value, no change. అంటే ఇక్కడ చేంజ్ అయ్యేవి ఏంటంటే n వాల్యూ చేంజ్ అవుతుంది. సో h వాల్యూ చేంజ్ అవ్వదు, 4 చేంజ్ అవ్వదు, పై చేంజ్ అవ్వదు, m చేంజ్ అవ్వదు, ఈ ఎలక్ట్రాన్ చార్ట్ చేంజ్ అవ్వదు. బట్ చేంజ్ దీస్ ఆర్ ఆల్ కాన్స్టెంట్స్. This constant by all constant we will get constant. So from this we can write radius equal to n square by z into just a constant. By substituting all these values we will get the constant by constant into constant is a constant. So by the removal of constant and equal we can put r proportional to n square by z. For a particular atom, r square proportional to n square by z. Here if so it can be written as r proportional to n square if z is constant. And ఒకే ఒకటే atom గురించి డిస్కస్ చేస్తున్నాం అనుకున్నప్పుడు r proportional to n square. It can be written as r1 by r2 is equal to n1 square by n2 square. And with the help of this equation we can write r proportional to 1 by z. So ఇప్పుడు n కాన్స్టెంట్ అక్కడ అంటే సేమ్ లెవెల్ ఉంది కానీ ఆటమ్స్ డిఫరెన్స్ ఉంది. సో అప్పుడు r proportional to 1 by z. It can be written as r1 by r2 is equal to z2 by z1. And the very important one, so what is this constant value? Now we got the relations from r to n and r to z. Atomic number ki radius ki ade orbit ki radius ki relations మనం find out చేస్తాం. అయితే ఇక్కడ h constant 4 pi mv square all are constant. So by substituting all these values we will get a constant already we said here. So what is the value of that constant is? So a constant values అన్ని substitute చేసి మనం calculation చేస్తే r equal to ఏమొస్తుంటే n square into 0.529 by z. It is in terms of angstroms by z. So radius of an orbit equal to n square into 0.529 by z angstroms. Okay, so this is the best, this is the expression for radius for the calculation. This is the main expression, this is the expression used to the calculation of radius of a given orbit. Okay, and the relation between radius, number of shell, nothing but energy level, and the radius and its atomic number. Okay. So he also given an expression for energy. Energy of an electron present in an orbit. He also given expression for energy of an electron present in an orbit. So what is that? Here energy is equal to given as minus 2 pi square m equal 4 by n square h square into z square. Okay, this is known as the expression for energy of an electron present in an orbit. This is En, nothing but present in this nth orbit. Here we know the n is orbit, number of orbit, h Planck's constant, mass of electron, charge of electron, pi value we know 3.14, 2 is constant, z is atomic number. Meaning again here variables are, what are the variables? N is variable, nothing but it means its value changes. So atomic number is also changed. So the remaining are constants. So we can write, so by substituting all these values, h is also constant. By substituting all these values we will get here approximately values given minus 313.6 by n square into z square. So this is the best expression to calculate the energy of electron. So it is also given in terms of other units. So other units means the energy is for example in terms of joules. In terms of joules it is equal to minus 2.18 into 10 to the power of minus 18 z square by n square. So actually this value is obtained by taking kilocalories. This value will be obtained by taking the units energy in terms of joules. Okay. If in terms of H energy equal minus 2.18 into 10 to the power of minus 11, we know 1 joule is equal to 10 to the power of 7 L's. So into z square is a variable. So this expression is used if you calculate the energy in terms of L's. Okay. Now what are the relations? So here E is proportional to, so energy is proportional to, inversely proportional to the N, but here the symbol minus is given. So we can write E proportional to N. If Z is constant, E proportional to N, that is E1 by E2 is equal to N1 by N2. Okay, so this is the expression, different type of expression. This is the main expression. So and the other units, there is some equations are there. So we need to remember all type of expressions in different units. For calculation, it is very helpful. Okay. He also gave an expression for the velocity of an electron. Moving nothing but revolving in an orbit. The velocity of orbit is given as 2 pi z e square by nh. Okay, here again n is variable, z is variable, 2 h e h, 2 pi h e, all are constants. We can write as V proportional to z by n. Okay, here again if you substitute all these constants, 2 constant, pi 3.14, h Planck's constant, E charge of electron. So by substituting all these constant and by calculated we will get 2.188 into 10 power 8 into z by n centimeter per second. If you use this, we are using the total units in CGS method, that's why we got the final value in centimeter per second. So this is the main expression to calculate the velocity of an electron present in an orbit. Okay, so next, another important one. He also given an expression for Rydberg constant. Already we know the Rydberg constant in Rydberg equation, which explains about the wave number of spectral lines in hydrogen spectrum. He also given an expression for Rydberg constant. Rydberg constant R here. Okay, so he given that equation R equal to Rydberg constant R equal to 2 pi square m e power 4 by ch cube. It is totally different to that all the equations just now we saw. Here all are constants, because R is a constant, the all values must be constant. These all values must be constant. 2 constant, pi, mass of electron, charge of electron, c, velocity of nothing but speed of electron, h. And it can be taken as the speed of light. Here h means Planck's constants. By substituting all these values, it is obtained that approximately 109,680 centimeter inverse. But already in the Rydberg's equation, we know that R equals 109,677 centimeter inverse. So that was the Rydberg's constant is given by Rydberg. So this is calculated from the expression given by the Niels Bohr. Niels Bohr just expression based cheskoni just not a. So what is the greatness of Niels Bohr theory means? He given equations for radius. ఇప్పుడు దాకా మనం డిస్కస్ చేసిన దాంట్లో రేడియస్ కి ఈక్వేషన్ వచ్చింది, ఎనర్జీ ఆఫ్ ఎలక్ట్రాన్ ఈక్వేషన్ వచ్చింది, వెలాసిటీ ఆఫ్ ఎలక్ట్రాన్ వచ్చింది. నెక్స్ట్ యాంగులర్ మొమెంటం mvr is equal to nh by 2 pi. Angular momentum equation is there and Rydberg constant equation is also there. So ఈ అన్ని వాల్యూస్ బేస్డ్ ఆన్ ఈక్వేషన్ తోనే హీ ఇమాజిన్, అంటే వీటి వాల్యూస్ పర్ఫెక్ట్ గా ఇంత ఉండొచ్చు, వాటిని క్యాలిక్యులేట్ చేయాలంటే సపరేట్ ఎక్స్పెరిమెంట్ చేయకుండా ఈ వాల్యూస్ బేస్ చేసుకొని, ఈ ఈక్వేషన్స్ బేస్ చేసుకొని వీ కెన్ క్యాలిక్యులేట్ ద రేడియస్, ఎనర్జీ, వెలాసిటీ అండ్ యాంగులర్ మొమెంటం. అయితే ఎక్స్పెరిమెంట్ చేస్తే వచ్చే వాల్యూస్ ఇవన్నీ మనకి ఎక్స్పెరిమెంట్తో చేసుకుని ఇచ్చిన ఈక్వేషన్స్ కాదు. దే ఆర్ జస్ట్ మ్యాథమెటికల్ ఈక్వేషన్స్, మ్యాథమెటికల్ ఎక్స్ప్రెషన్ బేస్డ్ ఆన్ క్వాంటమ్ ఫిజిక్స్, డిఫరెంట్ టైప్ ఆఫ్ థియరీస్ బేస్ చేసుకొని ఈ గివెన్ సమ్ మ్యాథమెటికల్ ఎక్స్ప్రెషన్స్. సో బేస్డ్ ఆన్ దట్ మ్యాథమెటికల్ ఎక్స్ప్రెషన్ ఇఫ్ యూ క్యాలిక్యులేట్ దీస్ వాల్యూస్, దే ఆర్ ఎగ్జాక్ట్లీ మ్యాచింగ్ టు ద ఎక్స్పెరిమెంటల్ వాల్యూస్. ఫర్ ఎగ్జాంపుల్ రేడియస్ మనం ఎక్స్పెరిమెంట్తో క్యాలిక్యులేట్ చేస్తాం, ఏదో ఎక్స్ వాల్యూ వచ్చింది, అదే రేడియస్కి సంబంధించిన ఈక్వేషన్ నీల్స్ బోర్ ఇచ్చిన ఈక్వేషన్తో క్యాలిక్యులేట్ చేసిన we will get the same value. So this is also treated as the greatness, nothing but merit of Bohr's atomic model. Okay, this is the Bohr's atomic model, and there is some we discuss later about this atomic model, merits, demerits, what is the success of this one, and how it explains the hydrogen spectrum. We see in the later class. Okay.